Okay, Assalamualaikum warahmatullahi taala wabarakatuh. My name is Mohamad Nasharudin bin Aznan, and I'm from RK23, which is Electrical Engineering. Today, I would like to present about our project, our power project, which is the investigation on three-phase Y-connected generator. Okay, firstly we will go through into the introduction. Okay, firstly, as an engineer, we are given a task to investigate and analyze an electrical system that consists of a three-phase Y-connected generator, transmission loss, and a load with acceptance power. We have looking according to the electrical supply application handbook V3, which is called ESAH version 3. In our country, the standard local electricity and supply authority is TNB, which is Tenaga Nasional Berhad. The three-phase electrical power is a common method of alternating current, a power generation, transmission and distribution. It also one of the common system used worldwide to transfer power based on the latest electricity supply books which is ESAHV version 3 that provided by TNB. The system that consists a three-phase system connected Y generator, transmission loss and load with acceptance power factor lagging, which is 0.8 according to the ESAH version 3 for voltage level 11 kilovolts. The frequency of load supply from the three-phase Y connected generator at line voltage is 50 Hz, which is this is the Malaysian standard 50 Hz. Okay, next we need to evaluate the parameter of the electrical system in the context of transmission and load acceptance, load impedance, currents, voltage and acceptable voltage drop based on BS 7671 or any Malaysian authority standard. Okay, the second we will go through about the objective of our project. The first objective of my project is to understand three-phase Y-connected generator, how this system is working. Second one is to study and evaluate the active power absorbed by the loads by using 2 wattmeter method and the conventional measuring method. And the last objective is to make sure students know about the Malaysian standard electricity supply, which means to make sure that all the students know the standard electricity supply in Malaysia, because in other country they will provide the different electricity supply. Okay, okay. Next we will go through about the methodology. Okay, in this task, students are randomly assigned the value of line voltage, which means every student in my class have different voltage. By using this value, we need to calculate the value of V phase. The formula of V phase we can look at the books. Okay, the value of transmission loss and the value of the load was determined by the student metric number. It have its own calculation, which can refer into the guideline given by the lecturer. Okay. Okay, about the result. First one, we need to calculate the V phase using our V line to line, which is my V line given by my lecturer is 11 kilovolts. After we get the V phase, we will calculate the I line IAN, IBN, and ICN. Okay, after we got all the I-line, IAN, IBN, and ICN, we will calculate the I phase A, I phase B, and I phase C using the value from IAN, IBN. Okay, next we will calculate the V phase for the load A, which in this formula we will use the value of I phase A that we got early, and the ZA, which is my metric number. After we got the V phase for the load A and continue, we will calculate the V phase for the load B. Same also, but we use the I phase B and ZB, which is also in the metric number that we given. Okay, after we got the V phase for the load B, we will calculate the V phase for the load C. Same also, we use the V phase C and the ZC that given in the metric number. Next, we will calculate the voltage drop. Which is we want to get the value of voltage drop in percentage. After we got the voltage drop in percentage, we will calculate the VLL for the load A, load B, and load C using the appropriate formula. Okay, after we got the VLL for the wattmeter method based on the ESAH version 3, for the PF value, power factor lagging, which is 0.8 for voltage 11 kilovolts. Therefore, we need to calculate the W1 and W2, because if we want to calculate the total power, we need the value of W1 and W2, and then we will sum up the both of them. Finally, we will get the total power. Okay, for the conventional method, the real power consumed by the load is using this formula. P load equal to 3 times V phase L, I phase L, and cos theta. We will get the power load that we want to get the result. Okay, we also use the program, the software, to draw the circuit and get the significant graph for my value, which is 11 kilovolts, which means every student will have the different graph. After we got the graph, we can see the waveform that produced by my system and with my value. Okay, next we will go into the discussion. Okay, from the result that we get, I can tell you that by using the V line to line that have been assigned for me, I obtain the value of the V phase. The value of V phase is used to get the I line of the IAN, IBN, and ICN. In the delta Y to Y connection, the value of I line is equal to value of I phase, so we don't need to calculate the value of I phase. After that, we must calculate the voltage drop. In order to calculate it, we must calculate the value of phase voltage first. They are slightly different amount of value that we obtain from the simulation against the calculation, but the amount does not give much impact to our result, because only have a little bit significant difference. By using the value of phase value, the voltage drop can be finally determined. Okay, next, for the wattmeter method, based on ESAH version 3 for the power factor value. I using power factor 0.8 because I get the voltage level which is 11 kV, which is in the ESAH version 3 is 0.8, which means if we get the other value of V line to line, the power factor also will give a different value. The total power is determined by using the value of VL and IL. Also, the result they obtain from the simulation is slightly different from the calculation. Even there is slightly different, the value should be not problem because still can perform well and does not give a much impact on the outcome. Okay, finally we will go through onto the conclusion. Okay, as the conclusion, we have accomplished our 3 objectives, which is to understand the 3-phase Y connected generator, to study and to evaluate the active power absorbed by the loads by using the wattmeter method and the conventional measuring method, and the last one to make sure the student know about the Malaysian standard electricity supply. As the conclusion, we have accomplished our main objective. The student have already investigated and understand about the 3-phase Y connected generator. Next, the student also have studied how to evaluate the active power absorbed by the loads by using 2 wattmeter method and the conventional measuring method. That have 2 different methods that have we go through already. And finally, the students also know about the Malaysian standard electricity supply because the Tenaga Nasional Berhad for the Malaysian standard electricity supply, the student will know the exact value for the certain V line to line, which means also the student will understand the information that needs to be fulfilled in order to get the perfect system that we want. Okay, I have used the student will know about the Malaysian standard electrical supply, which means that every student will go through onto the ESH version 3 to observe and to identify the value for the power factor for that we will need to get based on our V line to line, which means that our V line to line will give the different power factor, and also we have already investigate and understand the system that we need to produce a very perfect system which doesn't give the wrong or false system. Okay, finally also from my observation and calculation, there are slightly different value from the exact calculation and from the software that I use to get the value, but the slightly different in the value doesn't give a much problem because the value are not to have a big difference, which mean that will not give impact on our system. Also, the waveform that we get from the simulation, we can see about the flow of the voltage drop in our system, and we can get from the waveform also we can get the voltage, the current and the total power that we need to compare with our our main calculation. Although they have a slightly different, they will not give a much impact on our project. Okay, that's all for my presentation today. I would like to thanks to my lecturer because give me this opportunity to do this project, and I also learned very important things about the three-phase Y connected system. Thank you.